This is Mrs. Regan with just a quick little tip about how to help your student with partial quotient division. It's not what you're used to seeing in the way that you were probably taught, but partial quotient division builds on what students already know about multiplication facts to help solve long division problems in just small parts, little chunks at a time. So for instance, 935 divided by 4. You would still set the problem up the same way that you're used to seeing. 935 going in the big house and with a divisor of a 4 on the way outside. Some people call this method hangman because when you set up the problem, you make it look like a little hangman. All of our work is going to be done on the outside here in small little parts, one small part at a time. So for 4 as a divisor, we teach our students first to come over here and take a minute, slow it down, and just think about what you know about the problem. Sometimes with long division it's tricky because you have to have the multiplication facts stuck in your head. With partial quotient, we teach the students to just slowly ease into it, figure out what works best. Again, our divisor is 4, so we always use our divisor and first have the students think about, okay, that divisor times 1, times 10, times 100. That always gives us a really good place to start. 4 times 1 is 4, 4 times 10, 40, 4 times 100, 400. Now, we're trying to figure out how to get as close to 935 as we can. 400 is obviously a close place to start, but it's not quite close enough. So how can we get 400 closer to 935? This is where we teach the students, just start thinking about what you know about math. What if I double this 100? That means my answer in the product here would also be doubled. Okay, that's very similar to saying 4 times 2 is 8. So 4 times 20 is 80. 4 times 200 is 800. Simple concept, but then they can very easily see this. 800 is now a lot closer to 935. So when we're doing our partial quotient, here outside our hangman, this is where we write what did we multiply in small parts. So if I'm trying to get 935, I can get all the way close to 800 by multiplying 4 times 200. So 4 times 200 is 800. That's my first part to find my quotient, but it's not all the way. I still have something left. And when we say left, that's a reminder that we subtract. So how much do we have left? 135. Now if I come back over here to my ThinkPad, I don't have anything quite yet that gets me close to 135, but I could get there. I can think of 135 as almost this 13. How can I use 4 to get close to a 13? Well, if I know 4 times 3 is 12. 12 is not quite close to 135, but again, by the same logic over here, if I make that 3 a 30, just by adding a 0, I can make that 12 a 120, just by adding a 0. Now 120 is actually close to 135. So 4 times 30 gets me 120. I have another part of my quotient figured out, but I still have some left, so I subtract to see what's left over. And I'm at 15. My last piece, then I come back over here. 4 times 3 is 12. Some students might think, well, I wonder if I can get closer to 12. So after 4 times 3 is 4 times 4, which is 16. 16 is more than all I have to use. I only have 15. I cannot go over when I'm doing division. So I can't use 4 times 4 is 16. But it's still good to write it down there because I would rather make a mistake over here on my work than when I'm actually solving the problem. So I'm going to come back to 4 times 3 is 12. 4 times 3 is 12. I have a little bit left, which is a 3. This is exactly the same as the division you and I are all used to seeing. My divisor is 4. I can't possibly pull out 4 from what I have left over in the 3, so we call that the remainder. Now I've solved my division problem in small parts. This is where I go back and put those parts back together. First chunk I solved was a 200, and then I solved with a 30, and then I solved with a 3. If I go back in the end, outside of all my hangman work here, 230 and 3, when you add them all together, gives me 233. So my answer to 935 divided by 4 is 233 with a remainder of 3. That's the partial quotient division. It's very, very similar to what you're actually used to seeing in long division. And even though I'm not teaching this way to the kids, I'll show it down here just because I know a lot of parents are used to seeing it that way. And then once you see it side by side, you'll see how really connected these really are. In the traditional long division method, you would first just look at the first number. How many times can I get 4 into 9? Well, I can get it in 2 times. 2 times 4 is 8. And that gives me 1, and then I bring down the next number. How many times can I get 4 into 13? Well, just like what I did up here, 4 times 3 is 12, which gives me 1 left over, and then I bring the very last one down. And look, it's exactly the same way. I'm still stuck with a 15, which is another 3. 4 times 3 is 12, and I'm left with 3, and then I can't do anything left anymore. Now you might say, but this is so much quicker than the way that we just did it with partial quotient up here. And yes, it is. But here's what else I'll say to that. Up here, the students are truly understanding math. They're truly understanding number sense. Down here, they're just following a procedure, maybe not quite sure what it actually means. They don't understand that when they have an 8 here, it's really 800. They don't understand that when they have 12 here, it's really 120 with the missing place value over here. Plus, and here's the most important part, if students do it this way, they might do well in just this one unit in 5th grade. But later in our unit, 935 might be 93 and 5/10. It might be 0 and 4/10. When we add in decimals into the problem, this version of long division no longer works with decimals, and then your student will be completely lost in just a week. However, with partial quotient up here, adding decimals in, keep the problem exactly the same way. They won't go wrong as long as they understand the partial quotient division.